In this video, we're going to go on graphing a radical function. Remember that a function is a relationship where for every x, there's exactly one y. For every independent variable, there's exactly one dependent variable. So a radical function, of course, is going to have one radical. Another radical. In A, determine a vertical stretch or compression. Remember that if A is greater than 1, it's a vertical stretch. If it's less than 1, it's a compression. H determine the horizontal translation. So H is going to tell you where it's moving, right or left. K is going to tell you where it's moving up and down. The H is inside of the radical, the K outside. Now, it's important that for the domain and range, it's a little bit different if we have an even index or an odd index. The domain is going to be where X is greater than H, or, right, if by any chance my X has something in front, is wherever X minus H is greater than or equal to 0, right? So if X has something in the front, so this is what we're going to do. Now, the range, if, again, n is even, A is positive, then it's going to be Y greater or equal to K. And if A is negative and n is even, then it's Y less than or equal to K. If n is odd, then domain and range are real numbers, so we don't have to do anything from there. So let's start with this one and let's try to trace this graph, and we're going to substitute some values from there. So first of all, I know that this is a square root. So my domain is going to be wherever x minus 5 is greater than or equal to 0. So wherever x is greater than 5. So that's my domain where x is greater than or equal to 5. And my range, right here, my k is 0. So that means that my range is where y is greater than or equal to 0. Okay. Keep in mind that that is also my starting point. So 5, 0, we can call it vertex. So I know that my graph is going to start here. Okay. Now, I know that my domain has to be greater than or equal to 5. So that means that I cannot substitute for x any values that are less than 5. So that's why it's important to identify your domain first, because now we know what values we can substitute. Let's substitute a few. Let's say 6. So I got the square root of 6 minus 5. So the square root of 1. That is 1. So I got the 0.61. 61 is right here. Right? And let's say f equals to 7. So the square root of 7 minus 2. So actually, let's use 9. Let's use 9. So 9 minus 5 equals square root of 4. So this is 2. So I got 9. 2. So 9, 2. And that's my graph. Look, that is something like that. Oh, oops, I put that on the wrong place. So let's erase that one here. So it's 9, 2. It's up here, 9, 2. Right? And that's my graph. Don't forget the arrow at the end. So let's see the next one again. N on this case is odd. So that means that my domain is all real numbers, my range, and all real numbers. That means that now I can substitute anything here. Again, my h here is -1, k is 0, so that number is important. So -1, 0, -1, 0 is this point right here. Let's substitute a few points to the right. Let's say I want to substitute, let's say -2. So the cubic root of -2 plus 1. So the cubic root of -1 is -1. So that means that I get a point -2, -1, -2, -1. Okay. And then I want to substitute, let's say -9. -9. So the cubic root of -9 plus 1, the cubic root of -8. So this is -2. Look that I'm substituting values so I can try to get a perfect cubic root. So that's why I went all the way to -9. -9, -2. Now, my range is also a real number. So from here, I also have to find values to the right. So that means that I'm going to start substituting, let's say 0. So g of 0 equals to the cubic root of 0 plus 1. Cubic root of 1. So that's 1. So I got 0, 1. 0, 1. It looks like a 9, but it should be a G. So G. So that means 0, 1 is this one here. And let's substitute G of 7. G of 7. So the cubic root of 7 plus 1 is the cubic root of 8. So that's 2. So I got the 0.7. So 7, 2 is here. So my graph goes like this, something like that, arrows at the end. Next one, now I have that 1/2 there, right? So let's start with working with the domain. Again, that half would change the compression, right? But not going to change anything on the domain. So my domain is going to be where x minus 1 is greater than 0. So x to be greater than or equal to 0. So my domain is x such that x is greater than 1. Right? And then my range, again here, h is positive 1, k is negative 3. So my range is even, a is positive. So that means that this is going to be y, where y is greater than or equal to negative 3. So let's mark that points 1, negative 3, 1, negative 3. Now I'm going to substitute values. So y, let's say 1. Actually, not 1. It's 1, we already have it, right? Let's say 2. So y, 2 equals to 1/2. Square root of 2 minus 1 equals to negative 3. So 1/2 of the square root of 1. So this is 1/2 minus 3. Finding a denominator, I got minus 6 over 2. So this is the same as negative 5 over 2. That is approximately 2.5. So this is going to be the 0.2, negative 5 over 2. Negative 5 over 2 is approximately here. And then let's substitute here 5. So g of 5. 1/2 cubic root of 5 minus 1 minus 3. So 1/2 of 4 minus 3. So this is 2 minus 3 is negative 1. So I have the 0.5, negative 1. And there's my graph, right? So it's going to start there. The last one, so the next one here, n is odd. So that means that here domain is all real number, range is all real numbers, and we're going to work with those numbers here. Start with f, right? We know that h is 5, k is 1. So let's mark that point. So let's mark the point 5, 1. 5, 1 is this point here. And let's start substituting. Let's say I want to substitute 6. The cubic root of 6 minus 5 plus 1. Cubic root of 1 plus 1. 1 plus 1 is 2. So I got the 0.62. 62. Let's substitute, let's say, actually, I don't think that I have a space to substitute anything else with a perfect cubic root to the right. So let's go to the left. So let's say 4. To 4. So it's a cubic root. 4 minus 5 equals to plus, not equal, so just plus 1. Plus 1. So the cubic root of negative 1 plus 1. So negative 1 plus 1 equals to 0. So I got the 0.4. 0. So 0 is here. And let's choose then, let's choose negative 3. F of negative 3 equals to the cubic root of negative 3 minus 5 plus 1. So the cubic root of negative a plus 1. This is negative 2 plus 1 equals to negative 1. Negative 3, negative 1. So negative 3. And that's going to be my graph right there. And that's it. That's it for this video. May the fortune be with you.